The important thing in this bootloader is this is saying under, well, there's a VM Linux, that's the kernel. So you see that dash, it's over here. See the dash and then the version? That's the actual binary of the kernel that it's running. So I could have multiple kernels installed. This UENV.txt file gets read by the bootloader, decides which one it's going to load based on that setting of uname_r. This UUID would give you a way to specify which UUID to mount for the root file system. So I could force it to mount different root file systems. DTB, by default, it's going to read an onboard EEPROM to detect which board it is. The board says it's a Beaglebone Blue. It's going to load the Beaglebone Blue device tree, which will show where those files live here in a second. But if I wanted to change the device tree that it loaded on boot, I could specify it here. There's newer versions of this bootloader support this thing called overlays. For Beaglebone Black, each of the different Cape add-on boards will have an EEPROM identifier on it that specifies what overlay to load for that add-on board, and those will get loaded automatically. It doesn't matter so much here for Beaglebone Blue, but it's informative. You'll see I did make a modification to this one. There it is. I've got an overlay added for this I2S based audio device, and we'll kind of cover how to make that at some point.
Do you think a third-year undergraduate student would be able to figure out how to add an overlay for a new device?
Yeah,
that's useful, or do you think
not
it's
day one.
I mean, that's absolutely not the direction I was building the lab, because there's so much hardware, there's electronics,
Yeah,
there's
so I
lithium
think what
ion.
you do, I think you have somebody, somebody manage the image that people have a base with whatever hardware. So somebody's going to have to do that first level of integration, but they do that one time. Then you save off the SD card image, including these modifications to the boot overlay file, and then those get loaded when they put that SD card image, right? So they don't have to customize this. It gets customized once and put into the SD card image with whatever hardware they're going to have to go. Now, if they need to change it, if you need to turn something on and off, then you can ask them to simply put a hash mark or a pound sign or whatever you want to call it at the beginning of this file to load or not load that driver.
So we've so far developed everything with never having seen this file before.
Yep.
So what advantage does it get us to know about this file?
When you start adding things to the I2C and SPI and other buses off of these headers, and you're not using user space drivers, but instead you want to use kernel drivers, which is the way I'd recommend going.
What's a user space driver?
Okay. Forget I ever said user space drivers. They don't exist. So there are the kernel exposes certain. I mentioned everything in Linux is a file, right?
Yep.
There's an I2C file, right? So there's an I2C-2 file. That by interacting with that file, I can actually send commands to the I2C bus. So a user space driver would do just that. I would create an application that lives in user space that would then send I2C commands across that bus.
And they're more abstracted, and they're more.
Well, they're less abstract. I mean, those programs that send I2C commands, like that program has to understand I2C commands. Don't write those.
So we're relying.
Use drivers that turn I2C devices into files, like every Linux device driver does, and interact with the files that it creates, like sysclass LEDs.
Okay.
If I wanted to collect more LED, I could put an I2C GPIO expander, and I could connect a string of LEDs. but interact with the LED interface. Don't interact with /dev I2C. Don't do that. If you go and start stealing Raspberry Pi examples, and they're these Python examples, that's exactly what they'll have you do, and it's a horrible idea. Like, you'll find this piece of Python code that uses what they call I2C dev or spy dev, right? They call it that because it's this interface under the dev directory, and you're just from your Python user space application, you're going and talking to the bus controller. Don't talk to the bus controller. Let the kernel talk to the bus controller and talk to the device. It knows how to do. It does those things nicely. You just worry about finding that one. If there's not a driver, ask me. I mean, ask people in the community to get a driver for whatever you're hooking up, right? For this example, I did not write any driver code to talk to this device.
Right.
I didn't have to. The driver's already there. Linux is loaded with drivers. It knows how to talk to stuff.
So I want to see if I can find an example in our SCOTO software of a tool we're using to talk to a device and complete the understanding. Compare what we've done with what
Okay.
you suggested.
Yeah, so because I loaded that overlay, I now have, like, this won't work on yours because you're not loading this overlay. Because I've loaded that overlay, I've actually got an audio device, right? I can just play audio on this codec, right? So I just run things like ALSA Mixer, just high-level applications. Use the operating system integrations. Don't try to roll your own. Understanding device tree is important. That's why I've been spending so much time on it. Understanding this boot file is important because that's how I can load custom fragments of device tree. Do you have to push this on every user? No. What you have to do is get one system integrator to kind of understand the hardware that you want to do, and then tell individuals to turn on and off loading of certain drivers. Or load the drivers, and if the device isn't there, it'll just fail. Who cares, right? It'll just fail. It's not going to stop the system from running. And this audio one would never fail because it's all output. It never even reads anything back, so it would just work. It would just not be writing to anything. So anyway, there are some, like the PRU driver. There's a couple of different PRU drivers. That's the thing that communicates to the microcontrollers. There's a couple different ones that we can load. So that's configured here. The overlay that loads the driver for talking to those microcontrollers. And this thing called Cape Universal. I need to get to some of these other slides because there's slides on this thing called config pin. But config pin is this great utility. So we've got these helper drivers that allow you to avoid doing a lot of this device tree overlay stuff. If all I want to do is say turn this SPI pin into a GPIO pin or some other type of pin, I can use the utility called config pin to do that. Anyway, I won't spend any more time on that here. This is the thing I want to get to right here. The difference between a flasher image and an SD card image that you just boot and run off the SD card, or even the eMMC, is this magic line right there. That's the only difference. If this init program is a variable is set on the command line that says instead of running the standard Linux distribution, instead run this program. And this program is a flasher program that will copy all the files off of the image, partition, format the disk, and copy all the files off the disk onto the other disk. So if I had an SD card image that was based on one of the standard Beaglebone Debian images, and I wanted to turn it into a flasher image, I would simply uncomment that, save it, safely shut down, because you want to make sure that that change is preserved. Then boot off that SD card. It will now proceed to flash other ports. It'll do exactly what we did to start out this, right?
We did this by first creating a virtual link to the boot folder.
Oh God.
Then we
did that.
navigate here.
Oh, but all that is a way I can show you the files rather than doing it from the command line. Like those files are here. I could have done vim or nano. Right, those are other text editors that I can run from the Linux command line.
Okay, but where was the uboot directory?
Oh, yeah. Sorry, I'm a vim user. So var lib cloud9. All the contents of that tree on the left-hand side are all in var lib cloud9. /boot isn't one of them. In order to make boot show up in that folder, I created a symlink,
Yeah.
which you'll see represented by this little arrow.
How do I find the boot folder if I don't know already where it is?
It's at /boot.
Okay, so it's the top level directory.
Yeah, that is hard coded in the bootloader. So the bootloader itself, that application looks inside the /boot folder. And it looks for this file unv.txt, and this is all this name equals value pairs. The entire format is assigning variable names that the bootloader uses. And they're defined on these web pages, what those variables are. Including this uname R, which tells it which kernel it's going to load. And you'll see this is pointing to this opt scripts directory. There's a whole bunch of useful stuff in opt scripts. I'm just going to create a link to /opt. So you'll see in here this opt scripts tools, and you'll see that init eMMC flasher. So this is the one that's used to flash boards. The important one I want to show you here is actually under the developers folder, or no, it's under the eMMC folder. And I'll copy this name down once I find it. It's a horribly ugly name. Beaglebone Black, make micro SD card flasher from MMC. Self-descriptive enough? I'm gonna save that off in the Google Doc. So, if I want to make a new flasher image from the contents of the current contents of my eMMC, I simply run this shell script as root. Who can tell me what I mean by as root? As administrator. I can do whatever I want. There's no limitations to permissions. So what's the magic command I need to execute? Sudo. So gotta know that. That's like, there's so many things. You need to be cautious when you type in sudo because all the protections go away. I can do whatever I want without limitation. So the password for Beaglebone Blue, our default Debian images, is TEMPPWD. It's just magic. But you have to know this. So no sudo, no the Debian password. User is Debian. Don't capitalize that. It's TEMPPWD. And so if I wanted to create a SD